Hello everyone. This is R. Suresh Kumar, Assistant Professor, working as Assistant Professor in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So, in the previous lecture, we will discuss about some of the contents in the infiltration. So, the first one, infiltration and percolation, and also factors affecting on infiltration, and the measurement of the infiltration by applying different type of methods like the single ring infiltrometer and double ring infiltrometer and infiltration simulators can be using the calculating infiltration. Now we will discuss about the topic of W index and Phi index. So infiltration indicate the capacity of the soil does not remains a constant to absorbing the infiltration capacities. So by using this one, by convenient we have hydrological computations for computing the surface runoff as well as the flood discharge. The using of the infiltration capacity curves is not a convenient. So from this one we have diagram clearly you have to observe here the infiltration capacity can be observed by using the time durations in the x-axis and the infiltration rate in the y-axis. So from above you will the net storm of the rain can be calculated and the infiltration regime will be the by duration of the time how it can be reduced. The infiltration from peaks to decreasing of them can be known from this diagram. So next we have W index and Phi index. So infiltration can be average infiltration indications can be known by applying this Phi index and as well as the W index. What is meant by Phi index? Phi index is nothing but the average rainfall above the which the rainfall volume is equal to the runoff. So it is called a Phi index. The average infiltration rate during the period of the rainfall excess, and the rainfall excess is also called as runoff as we know very well, and is rainfall contribution of runoff and the period of during which the such type of the rainfall takes place is called period of rainfall excess. So that is in the Phi index, how to calculate the infiltration capacity by using the etograph. Here the etograph, what is meant by etograph? Etograph is nothing but to draw the graphical representation, duration in the x-axis and also the intensity in the y-axis. So from this, the above will be have, the bottom will have calculated the unshaded portion we call it as Phi index, and above the shaded portion we call it as rainfall excess. So for determination of Phi index, the horizontal line is drawn of etograph, and in the what is difference between hydrograph and etograph will be discussed later. In the etograph here majorly can be difference between the time duration in the x-axis and the rainfall intensity in the y-axis. From this one, here the non-shaded portion as already discussed. From this one, we have to find the volume of the surface runoff. The unshaded portion has a horizontal line representing the losses of the including the interception, but it is assumed that loss due to the infiltration only. The amount of rainfall excess of Phi minus Phi index is called rainfall excess. Rainfall excess nothing but we call it as runoff. The amount of the rainfall in excess of Phi index is called rainfall excess. That is by using the etograph, you have to find out the Phi index of the infiltration. The Phi index is derived from the rainfall etograph, which is known as resulting the runoff volume. So next, the initial losses is considered as part of infiltration, and part of infiltration can be and F is equal to Phi is rainfall intensity and F is the infiltration rate. In estimation maximum the flood is designed the purpose. Phi index value is 0.10 centimeters per hour can be assumed. Then the rainfall intensity of the Phi index is equal to effective minus Phi index is equal to effective rainfall intensity. So that is the from this equation, the rainfall intensity we have to find out is equal to here rainfall intensity and the Phi index, and the effective rainfall intensity can be known from this using the small equation. Next, Phi Index. There is a one formula to calculating the Phi Index. Here the average rate of the rainfall above the rainfall volume is equal to the surface runoff volume. Then Phi is equal to P minus R by TE. By applying this one, you have to find out from the etographs. As I explained in before, the unshaded portion we are going to be called as Phi Index, and shaded above the rainfall excess, the portion which is already shaded is called rainfall excess. So here phi is equal to P minus R by T. Here Phi Index is equal centimeters per hour, and P is equal total rainfall in centimeters, and the R is equal to runoff in centimeter, and T is equal to time period for the rainfall excess. From this, applying this equation, we have to find the Phi Index, and the apply by using the etograph only. By using the etograph, we have to find out the rainfall excess here. So that is the equation to find the Phi Index. And next, W in the Phi Index can be where it can be used. The applications of the Phi Index, very important point here we are discussing. The application of the Phi Index can be estimated surface runoff from the given etograph. It is especially useful for the predicting the infiltration from the storm occurring in the very large basin. That is only the second point we have to application of the Phi Index. Next, third point is it is useful for the unit hydrograph analysis to determine the pattern of the rainfall excess. So what the hydrograph, how can you calculate the hydrograph, can draw the hydrographs from the given data, can be discussed in the next chapters. So here we have to find out the only etograph. From the etographs, how to calculate the Phi Index. So assume the Phi Index can be calculated and can be derived by equation by P minus R by TE by applying the equation. So next one is double index. So what is meant by double index? Double index and is the more accurate than the Phi Index because interception and depression losses, which is considered as part of infiltration. So what I said? So here the double index is the interception and depression losses, which are considered as part of infiltration. So that's why we have to consider double index is always less than the Phi Index. Here, so interception losses and depression loss also considered here. So from this one, why? Because some of the times the interception losses can be calculated very difficult. So that's why double index is not commonly used as in the practices. Why? Because we are discussed in the previous lecture, the interception losses can be evaporation of losses from the atmosphere in the above the leaves can be evaporation. So it is very difficult to calculation the such type of the evaporation values. So that's why that is very difficult when compared with the Phi Index of the double index. So here double index is also calculating some of the formula. By applying the formula, we have to find out the double index. So see here, double index is equal to the average rate of infiltration during the period when the rainfall intensity exceeds the infiltration rate. So here double index is equal to P minus R minus S minus T. This is the formula to find the double index. P minus R minus S minus T. Let us see the notations of this one. This formula is equal to R is equal to total runoff in centimeters, S is equal to total losses in centimeters, T is equal to total time period for calculating the double index. So that is the double index value. In the double index is the average rate of infiltration is centimeters per hour. As generally the double index is more accurate than the Phi Index because it excludes the depression and interception losses. As a previous slide we discussed about it is best for the double index is more accurate than the Phi Index. So exclude the depression and interception losses. So that is the reason we have to find the exclude the impression and interception losses. So Phi Index, that is the difference between the Phi Index and double index. Here the Phi Index is the rate of infiltration exceeding which the volume of rainfall becomes equal to the runoff. This is the important point here we have to remember. So the rainfall becomes equal to the runoff volume. Rainfall volume equal to the runoff. That is the Phi Index. Next, what about double index? It is the average infiltration rate that is calculated during the time when the intensity of the rainfall exceeding the infiltration rate. Here, exceeding the infiltration rate. That is the Phi Index. That is the major difference between the Phi Index and double index. It is very important point in the gate for written the gate examinations and any other competitive examinations. The difference between the Phi Index and double index is very important. So double index is much more accurate than the Phi Index because it is suitable for the initial losses also. That's why you have to prefer the double index also. So this is the measure as we discussed about the double index and Phi Index. So by solving some of the numericals of the Phi Index, let us see that one. The total observed runoff volume during the 6 hours storm, which is the uniform intensity of the 1.5 centimeters per hour, is 21.6 into 10 to the power of 6 meter cube. If the area of the basin 300 kilometers square, find the average infiltration rate for this basin. That is the problem is given. How to solve this one? This is solving the total rainfall is equal to intensity of the rainfall. Here see that intensity of the rainfall into duration of the rainfall. That is equal to 1.5 into 6. That is equal to 9 centimeters for a total rainfall. Next, volume of the runoff is equal to already given 21.6 into 10 to the power of 6 in the my given data. So area is given also given from the 300 kilometers square, 300 into 10 to the power of 6 kilometers square. Area of the basin 300 kilometers square, 300 into 10 to the power of 6. 300 into 10 to the power of 6 here. Depth of the runoff is equal to 21.6 into 10 to the power of 6 divided by 300 into 10 to the power of 6 is equal to 0.02 meters. That is equal to 7.20 centimeters. 7.20 centimeters. Next, depth of the infiltration is equal to depth of the rainfall minus depth of the runoff. That is, depth of the rainfall is already calculated in the above is equal to 9 centimeters and the depth of the runoff is equal to 7.2 centimeters. That is equal to 9 minus 7.2 is equal to 1.8 centimeters. That is average infiltration rate is equal to 1.8 divided by 6. That is equal to 0.30 centimeter per hour. So this is the problem, simply problem here. What we have done, total rainfall is equal to intensity of the rainfall into duration and the volume is given, area is given and depth we have to find. Any of the depth is find and depth of the infiltration. Depth of infiltration is equal to depth of the rainfall minus depth of the runoff. So that is the minus depth, that is equal to 9 minus 7.2, that is 1.8 centimeters. The average infiltration rate is equal to 1.8 divided by 6, that is equal to 0.3 centimeters. Another problem, let us see, that is a textbook problem by Jairam Reddy sir. So here 6 hours storm produced rainfall intensities are 7, 8, 25, 12, 10 and 3 mm per hour. Is successive 1 hour interval over the basin of 800 square kilometers. The resulting runoff is observed to be 2640 hectares meters. Determine the Phi Index for this basin. Determine the Phi Index. In this one, there is one diagram is given regarding this above problem. So which is related to that one. The time duration is how much? 1, 2, 3, 4, 5. Each of the content 1 hour given. Here the Phi Index can be assumed it as 8 mm per hour and the rainfall intensity is equal to 0, 5, 10, 15, 20, 25, 30 like that they are given. So from this one, total volume of the runoff as is already given in the given data 2640 hectares meters. So 2060 and 40 into 10,000, we are multiplying that 264 into 10 to the power of 5 meter cube. We are converting like that. Next, area of the basin. Area of the basin we have to find, already given the 800 into 10 to the power of 6 meter square. So depth of the runoff, depth is equal to volume and volume divided by area. Here is any of these volume is equal to any of them area multiplied by depth. Here we have to find out the depth. D is equal to volume divided by area. So that's why I applied this one. 264 into 10 to the power of 5 is the volume, and 800 and 10 to the power of 6 is equal to area is given. By solving this one is equal to 33 mm. So by trial and error method, Phi index is chosen as 80 mm per hour. We have to assume total rainfall volume of the Phi index is equal to. So we have to find the here 0 plus. By trial and error, here let us see by applying the formula. What is the formula? In the Phi index previously we have to P minus R by T. P minus R by T. From this formula, we have to P is equal to rainfall excess. From the previous one, what they are given? In the first one, there is no shaded on that one. So, no shaded area here. So, that's why we have to keep it as a 0. We have to keep it as in certain area. So, 0. So, that's why you have to take the values of the 0 plus and again. So here plus 18 minus 8. What is meant by 18? 18 is already given in the rainfall intensities are given. That is equal to 18, 25, 12, 10 like that. So 18 minus what is 8 is equal to Phi index. What we are to be assumed. So plus 25 minus 8. Say similarly. Plus 12 minus 8 is plus 10 minus 8 plus 0. That is equal to 0 plus 10 plus 17 plus 4 plus 2 plus 0. By adding all this one, we have to be value of 33 mm. This is exactly equal to the observed runoff. Exactly equal to the observed runoff. So, what is observed runoff? In the previously, what we have to calculate in the above C, that one 33 mm. So here also 33 mm. So this is exactly what we are assumed Phi index is correct, 8 mm per hour. If it is not correct, we can trial it number. So again the 0 plus 18.8 plus here P minus R by T means let us see P is equal to rainfall intensity, 18 is given minus 8 is Phi index given divided by 1 plus 25 minus 8 by 1 plus 12 minus 8 by 1. So like that we have to find the calculation the values of each and every values of the by using the equal to runoff value. Therefore the Phi index is equal to 80 mm per hour is calculated. This is very important problem. Number of times is given in the GATE exams also. So 6 hours term just given the rainfall intensity is given and hours is given, so area is given. By use observing the 2006 area is given, determine the Phi index of the basin. Already we solved this. So second problem is also. Hope to understand this one. And another problem is the rainfall on 3 successive 6 hours periods are given are 1.3, 4.6, 3.1 centimeters. If the surface runoff resulting from the storm is 3 centimeters, what is the value of Phi index for this storm? What is the value of the Phi index for this storm? They are asking. So the resulting runoff is 3 centimeters. So the resulting runoff already given the 3 centimeters already given here 3 centimeters. By trial and error method, we will find out the Phi index line is equal to rainfall intensity minus Phi index. In the previously, we will draw the such type of the formula. So that the value is equal to what happens? 1.3 minus 4.1. Here 1.3 is given in the rainfall into period of successive 6 hours period of 1.3, 4.3.1 of successive runoff is given. So what is meant by 4.1? 4.1 is we are assumed the Phi index chosen for the for such type of the calculation of the Phi index. So we are assuming the 4.1. So here P minus R by T, that is equal to 1 by into 6. Here 4.6 minus 4.1 into 6. Here plus 3.1 minus 4.1 into 6. 6 means why we are multiplying the 6 our system is given. That is equal to 0 plus 4.6 minus 4.1 into 6 plus 0 is equal to 3 centimeters is totally given. Therefore, the rainfall in Phi index of this 4.1 centimeters is correct. How can you say? Here already the resulting runoff is equal to 3 centimeters are given, and what we got, the value of assumed Phi index is equal to 4.1 centimeters. Why these two are matching? But in the examination, how you have to find? This is very typical. But by practicing of the more, you can assume it some of the values of the Phi index by trial and error method. Maybe 2.5, 2.6, 3.1, 4.2, 4.5 like that. You have to try near the values you have to find. But here already calculating the values is given for you for your convenient, and 4.2 is we are assumed, and the Phi index value also came for the calculation by calculating 4.1 centimeters per hour. So these two are the correct. That's why by using the resulting of the runoff, 3 centimeters is given for the calculation of the runoff. So another problem is there. So a storm over the catchment area of 72 kilometers square was observed 2 centimeters per hour per 2 hour and 3 hour per next 3 hour. The surface runoff was plotted on the graph paper with the scale of x-axis and 1 centimeter 0.5 hours on y-axis. 1 centimeter is 10 meter cube per second. The area under the surface runoff hydrograph was measured to be 80 centimeters square. Find the Phi index of the infiltration. So let us see the problem is here. 1 centimeter square area graph is given. The runoff volume is equal to 10 into 10, 0.5 into 3600, that is equal to 18,000 meter cube is given. For 80 centimeter square, how much you are given? 18,000 into 80 meter cube. And the depth of the runoff is equal to 18,000 into 80 divided by 72 into 10 to the power of 6. Sorry, it is 10 to the power of 6. So, this is equal to 0.02 meter, that is equal to centimeters. By trial and error, every time by trial and error method, we are assumed the Phi index is equal to 2.33 centimeters per hour. Then the runoff volume above the Phi index is equal to 0 plus 3.2 minus 3.3 into 3 is equal to 2 centimeters absorbed runoff. So how much we got the value? 2 centimeters. We are assumed here 2.33. So that's why hence Phi index value is we are consider it as 2.3 centimeters is correct by applying the trial and error method. This is the formula to find the Phi index value. Hope you understand this type of double index and Phi index, the difference between double index and Phi index, and also solved some of the problems regarding the Phi index. Hope you understand. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.